Hello and welcome back to another video by Johnny, and in this video it's episode 4 of the chemistry episodes. Okay, so in this video I will talk about naming of organic compounds. Continue, of course, because in episode 3 I already told you how to name like oxides, metal oxide and non-metal oxide. So in this video we'll talk about bases and some common acids. Okay, so first of all, what is a base? A base. So basically there used to be the older definition of base. You might think that a base is like it has to have the OH minus. You might think that a base must have an OH minus. But that definition is no longer valid because we have exceptions. Like for example here, ammonia is a base and it's a weak base, and apparently when you put into any solution, and you put into water, it becomes our alkaline solution. So alkaline solution, the solution is alkaline, which means the pH of that has to be bigger than 7. Okay, so what is a pH? It's just like, how can I say, indication of how acidic or how basic it is. So alkaline also means basic, which is the opposite of acidic. Okay. So now what happens here is that we have a new theory. It's not new, I know, but it's a newer theory compared to the last one, which is called Brønsted-Lowry theory. So these two people, they came up with a theory that basically an acid is the proton giver, or they donate the protons. In this case, proton is a H+. Proton is a H+. And a base is a proton acceptor. So as long as you have the lone pair of electrons, if you have extra places for the H+ to go in there, or if you can accept the H+, you are a base. Okay, so let's come back to the naming for a moment. So you can see there, alright, most of the cases it has OH minus, right? And why the OH is minus? Let's look at this for a moment. Hydrogen is in group 1, which means it's likely to lose 1 electrons rather than gaining 7 more to get a full stable octet. So that's why it will lose 1 electrons. It becomes +1 in its oxidation state or oxidation number. Oxygen, on the other hand, is in group 6, so it will be more likely to accept 2 more electrons, so it becomes -2. Okay, so a -2 and a +1, so generally you have -1 for this OH minus ion. We call it the hydroxide ion. Okay, so we have a few common ones here: sodium hydroxide, potassium hydroxide, lithium hydroxide, magnesium hydroxide, calcium hydroxide, barium hydroxide, and so on. So I already listed for you like some equations here, but I'll talk about it later. Okay, for the bases, the naming is pretty easy. It's very similar to the metal oxide because that's exactly where it comes from. If you think about it, for example, sodium hydroxide, it's actually come from sodium oxide. Put in water and you get NaOH. So basically it has to have some relation, right? So the metal oxide and the bases. So the naming should be similar as well. For example, here, the transition metal, you can see we have iron 2 and iron 3. So here it's iron 2 hydroxide and iron 3 hydroxide. Okay, we have copper 1 and copper 2. So here is copper 1 hydroxide, and here's copper 2 hydroxide. Oh, the nickel, I mean the other metals, they're probably gonna have 2 plus. I mean plus 2 in the oxidation number or oxidation state. So probably gonna be just one kind of nickel. So you have nickel hydroxide. This is nickel hydroxide. Okay. Okay, so in this part, I'm gonna tell you how to name the acids. So first of all, what is an acid? So according to the new theory of Brønsted-Lowry, well, an acid is a proton donor. So it donates the proton, or it donates the H+. So when it donates the H+, it makes the solution acidic, which means the pH of a solution has to be smaller than 7. Okay. So there are several ions I listed here. They are all anions, and these are the result when the acid dissociate. So what does dissociation mean? Dissociation means dissociation. Dissociation means like when, for example, when HCl dissociate, it's gonna become H plus and Cl minus. So dissociation is when something become ions. Okay. Right. When you put into a solution, when you put into like watery environment. Okay, so here are some common ones, common acids. I already listed the oxidation number. Also, as there are 2 ways to name it. You will understand why it has to be extra way to name it later when we go into the salt. Okay, but here HCl, hydrogen chloride, or we can call them chlorhydric acid. I would recommend you to try to pronounce these names so many times, or just try to write it down so you will remember it in your study, okay? So hydrogen bromide, hydrogen iodide, hydrogen fluoride, as long as they don't have oxygen in there, they're gonna have the ide endings, okay? Fluorhydric acid, iodhydric acid, bromhydric acid, and chlorhydric acid. Okay. Oh, there's one more. H2S, hydrogen sulfide. There you go. Sulfur, and then ide becomes sulfide, not sulfuride. You know, because sulfuride doesn't sound nice enough, so that's becomes sulfide. Now, and then sulfurhydric acid. Okay. Any question? Okay. This kind of naming indicates that there's only hydrogen and sulfur in this acid. So this kind of naming tells you that this is an acid, right? And what is inside. Okay. However, it doesn't really tell you what kind of ions are in there. Like for example, here I knew it's gonna be an unsulfide, or S2. So S2 minus. S2 minus ion in there, and then there's a hydrogen, which is going to be H plus. So I think both kind of naming has their pros and cons, their benefits, and then their drawback as well. So maybe it's I think it's better if you try to learn them both. Okay. Now, there comes the acid that has oxygen in there. Why oxygen has to involve in everything? Okay, and there you go, H2CO3. Can you guess where the acid comes from? H2CO3? Yes, it comes from the CO2 that we learned before. When you combine CO2 and water, acid rain, you know, it becomes our hydrogen carbonate or carbonic acid. So what is the rules here? What is the rule for naming the acid when you have lots of lots of oxygen in there, or low number of oxygen? The rule is that if you have more oxygen, the naming is gonna have the 8, A-T-E, 8, or ic, I-C, ic, or 8 endings. Right, and the less oxygen it has, if it has less oxygen compared with this one, it's gonna have an I-T-E, ite, or us, O-U-S, us endings. Okay, just try to understand like this. If you ate too much acid, you're gonna get so sick. I mean, that's a mnemonic, the way maybe the way for you to remember it. And then if you eat less, then if you despite the food, eat the food, you're gonna be poor, let's say. I mean, sometimes it doesn't make sense, but bear with me. Okay, so here you go. H2CO3 is the only form of the acid with carbon here. So, I mean, normally there would not be something like hydrogen carbonate, right? Because you just want to have something richer. You want to be richer, right? So you name it rich. 8. Hydrogen carbonate. The other name, it becomes carbonic acid. Carbonic acid. Right. Let's come to another example. These two examples of HNO2 and HNO3. So what do you have here? You have less oxygen and more oxygen here. So it's gonna be hydrogen nitrite. Be careful, because you also have nitride with IDE. So you better pronounce it correctly. Nitrite and nitride is different. The nitride is basically the N, I think N3 minus, I think, ions. I'm not so sure about it. I'll check it out. I'll check it later. But the spelling is important, okay? And hydrogen nitrite will become nitrous acid. So more oxygen, hydrogen nitrate, and it will become nitric acid. Nitric acid. Okay. More example here. Can you try to pronounce it? Also, do you know where they come from? This one has less oxygen, this one has more oxygen. Do you know where they come from? This one comes from the P2O3. This one comes from the P2O5 that we learned in the previous episode. Okay. So, this one has more oxygen. Hydrogen phosphide. I know this one is phosphorus, right? You might think phosphorus plus ite is gonna be phosphorite or something like that. But the name is too long, so they shorten it to become phosphite and phosphorus acid. Hydrogen phosphate, more oxygen here, become phosphoric acid. Phosphoric acid. Now, let's try these cases. Let's try these special cases. When you have so many options, there are so many forms of the chloride, the chlorine containing acids. So you can see here, there are 4 different forms I can remember. The question is, how could you know which one is which? How could you know which form exists? The answer is very simple but very painful. You just have to memorize it. Try to write them down, try to maybe pronounce correctly, try to read it out loud, try to write them many times, you remember it. Okay, so where shall we start in here then? Okay, we start in the middle. This one has less oxygen compared to this one. So that's why it has the ite ending, and this one is 8 ending. But then, someone who is poor in oxygen is even poorer in this case. So you use the prefix hypo. You know hypo is very low, right? Hypo means low. Like for example, hypotension means low blood pressure. And then when you're rich in oxygen already, but you're even richer, you use the word hyper. You know, hyper means high, so for example, hypertension means high blood pressure. But here, hyperchlorate seems a bit too long, so they cut it short. Perchlorate. Okay. Any question? Okay. Hydrogen hypochlorite. Or the name is hypochlorous acid. Hydrogen chloride or chlorous acid. Hydrogen chlorate or chloric acid. Hydrogen perchlorate or perchloric acid. I hope you're not getting confused here because it sounds like a language class now. But basically chemistry is about the language of the chemicals, as well. Alright? Now, if you go on, there are some special cases. Try to guess what's the name of this form. This is the only form of Br and then it has oxygen in there. That's right, it's similar to this one. So, hydrogen bromate. So what's the other name? 8 become ic. So bromic acid. There you go. And then there are some other cases like like MnO4 minus. That's the permanganate. A lot of the rich, even richer in oxygen. Permanganate become permanganic. So hydrogen permanganate become permanganic acid. Alright? Alright, and then now you have the two special cases of the chromium and oxygen. Chromium is a transition metal, and they have very beautiful spectrum of color. We'll get to there later in later episodes. So here you have one chromium, two chromium here, so you use dichromate. Remember? Mono, di, tri, tetra, penta, hexa, hepta, something like that. There are some exception here. Okay, so hydrogen dichromate and chromate. So dichromate become dichromic acid and chromate become chromic acids. Okay, so there are several ions here together with their charge. I'll take a picture. Maybe I don't need it, but you can just pause the video for your study. And I hope the video was not too long, and thank you so much for watching. Bye. See you.